Dear friends, welcome back to the project Snow Queen. In this video, I will give an overview of markets that use low temperature refrigeration. My goal is to demonstrate the scale of commercial and scientific activities that use low temperature systems. And by low temperature, we mean everything which is lower minus 30 degrees Celsius. I will also make a projection for future product and service strategies that would use low temperature refrigeration technologies. We begin with the frozen food market that has operating temperatures from minus 30 degrees Celsius to minus 70 degrees Celsius. It had a size of $250 billion in 2015. And in 2020, it is expected to have a size of $306 billion. The frozen food market uses mechanical freezers and liquid nitrogen systems to provide the negative temperatures in the range of minus 30 degrees Celsius and minus 70 degrees Celsius. Enabling factors that help this market include busy lifestyle of urbanizing world. For example, it is expected to have plus 2.5 billion people in Asian cities by 2050. Convenience and hygiene of ready-to-cook meals, which are now more and more easier to order through online. And of course, the production technologies, including blast chilling and shock freezing, that help to preserve maximum taste, vitamins, and minerals of frozen food. Limiting factors include high maintenance and logistics costs for low temperature refrigeration, regulations against greenhouse gases, for example, the European Union Law number 517, and the competition over price and quality in Asia between local producers and multinational chains. Well, you can interpret these enabling and limiting factors as you may want. In my opinion, these factors define the following scenario for food production. Food producers will increase food quality and increase scales of production in order to reduce the costs, including the costs imposed by the environmental regulations. And all of this to beat competition and serve increasing market demand. Please note that we are talking about high quality products in the frozen food segment, which means that it employs expensive, low temperature refrigeration. Now we are moving to freeze drying market. Freeze drying is the technological process to dry liquid out of the product. This is achieved by first freezing the product and then putting it under the condition of vacuum. In these conditions, solid ice directly transforms into the gaseous state, and thus liquid could be easily removed from the product, providing a high quality drying. The operating temperature ranges from minus 60 degrees Celsius to minus 105 degrees Celsius. It had a size of $16 billion in 2020, and next year it is expected that the market will have a size of $31 billion. The freeze-drying market uses mechanical freezers and liquid nitrogen to provide temperatures in the range between minus 60 and minus 105 degrees Celsius. Enabling factors include development of pharmaceuticals with increased shelf life and increased quality, such as vaccines, proteins, hormones, or blood plasma. The second factor is high quality of freeze-dried, preserved products such as food, leather, and flowers. On the other hand, limiting factors include shortage of skilled personnel to operate and scale up freeze-drying systems, high ownership costs of freeze-drying systems that cause small industries to prefer traditional drying techniques. Next is the rising adoption of second-hand freeze-drying systems in order to cut costs. And last but not least, the sector will be influenced by regulations against greenhouse gases. So together, these enabling factors and limiting factors suggest the following scenario for the sector development. Freeze-drying sector will undergo standardization and increase of scales through centralization. All of this in order to reduce ownership costs and go from old freezing techniques and second-hand freeze-drying systems in order to improve the quality of dried products. Here it is important to mention again that in order to produce high quality freeze-dried products, we need to have an affordable and controllable, efficient and eco-friendly refrigeration system. And this is one of the key problems that needs to be solved. The next market is biobanking, which stores biological materials from humans, primarily for medical purposes. The market operates temperatures from minus 70 degrees Celsius to minus 196 degrees Celsius. It had a size of 52 billion in 2017, and in 2025, it is expected to grow to the size of $74 billion. The biobanking uses a variety of mechanical freezers and liquid nitrogen storages to provide temperatures in the range between minus 70 and minus 196 degrees Celsius. Enabling factors for the market include regenerative medicine to treat sclerosis, Alzheimer's, other autoimmune diseases, diabetes, rare genetic diseases, and cancer. In parallel, we have the development of precision medicine that allows to reduce costs for drug discovery and clinical research. Considering these two factors, we observe increased governmental and private support of this segment and increase in standardization and centralization, which helps to increase profit margins. Limiting factors include ethical and legal issues, since we are dealing with biological materials of human. There are decentralized biobanks currently with different standards, which reduces the quality of biological materials and their storage data. There is no single solution for storage equipment. Biological materials require different temperatures, and therefore there is a need to operate different freezers, which makes it complicated. Due to these limiting factors, we see low profit margins for biobanks. And in addition, biobanks will be influenced by the regulations against greenhouse gases, although not to degree of frozen food market, because in particular regulation in the European Union bans refrigerators before 2020, which freeze products at the temperature before -50. Here we operate at the lower freezing temperatures. Therefore, the only influence that could be expected from this regulation is related to the operation of greenhouse gases as such. And such regulations include the certification of personnel operating the gases and the systems that they use. Require checks for leakages, labeling, record keeping, and so on. From these enabling and limiting factors, we can make a conclusion for the future development of the sector that biobanks will obtain more public support, will undergo centralization and standardization, and these measures will be implemented to increase profit margins, naturally through the reduction of costs and including the costs of refrigeration equipment. And here I repeat again that we are considering advanced medical products in regenerative medicine and precision medicine that would allow to keep the population healthy in the upcoming future. And therefore, the requirements for refrigeration systems are significant. Now let's move to superconductors market. Here we will primarily talk about high temperature superconductors that demonstrate very low resistance to electrical current, almost close to zero, in the temperature range between -138 and -196 degrees Celsius. This is an example of application for superconductors in MRI machines. I myself have been diagnosed in MRI machine for about 3 times, and using superconductors improves the performance of MRI machines for at least 2 times and sometimes even more, which means that you spend less time in this intimidating device, and the quality of images is much better. Perhaps due to these advantages, the market in 2016 had the size of 2.7 billion and is expected in 2020 to increase to $3.5 billion. The superconductor market uses sophisticated mechanical freezers and liquid nitrogen in order to provide quite low freezing temperatures in the range between -136 and -196 degrees Celsius. Enabling factors for the market include the ongoing growth of diagnostic equipment in healthcare, including, for example, MRI machines with 5% growth rate. And this part of superconductor market takes about 75% share, quite significant. The second factor is the adoption with 6% rate of high temperature superconductor wires for power transmission and generation sector, including AC and DC cables, fault current limiters, renewables, and transformers. Now, limiting factors include still quite challenging threshold cost for materials, which has $10 per kiloampere meter for mass market and $50 per kiloampere meter for niche markets. The manufacturing of high temperature superconductors is quite challenging. The market itself is very fragmented, and refrigeration for these low temperature ranges is quite expensive. And again, the sector will be influenced by the regulations against greenhouse gases used in the expensive refrigeration systems. So enabling factors and limiting factors suggest that superconductor market will seek in the future the ways to reduce the cost of refrigeration, and will be naturally gravitated to companies that provide sophisticated cryogenic equipment for the operation of superconductor devices. One more time here we see how advanced high-quality products with outstanding properties require low-temperature refrigeration, and the cost of this refrigeration is again the problem. So having an advanced refrigeration system which is affordable, efficient, and functional in the large low-temperature range is very desirable for flourishing of this market segment. All right, liquefied natural gas market. Welcome to the Premier League. Liquefied natural gas, from its name, is a natural gas liquefied under very low temperature of minus 162 degrees Celsius. Conventional natural gas under this temperature reduces its volume for about 600 times and becomes liquid. So then it could be packed on a tanker and shipped to destinations to which building a pipeline will be feasible economically. Perhaps due to these reasons, we see the growth of this market, and also due to comparative environmental friendliness of natural gas comparing to gasoline, coal, and other carbon-based fuels. It was estimated 265 million tons in 2016, and in 2025 it is expected that the production will reach 400 million tons. To give you a perspective, 265 million tons is about 6% from global oil consumption. The liquefied natural gas market operates very complex mechanical freezers that provide temperature minus 162 degrees Celsius. Enabling factors for the LNG market include the demand from natural gas distribution, petrochemicals, power sector, mining and industry, quite expectedly. Favorable governmental regulations, including investments in fuel substitution, investments in infrastructure, and all these factors together led to reduced costs of LNG, so the market gets traction. However, limiting factors include insufficient pipeline infrastructure in remote areas, dependence on the substantial natural gas spreads that is pumped traditionally in pipelines, because LNG is more expensive than traditional natural gas for about 30%. So the producers need to observe quite carefully where the price of the natural gas currently is the highest, and then they could offer an alternative, an LNG, and make their profits. Now, another factor is that liquefaction takes about 30% of the total value chain cost, beginning from the production of natural gas at the extraction wells to regasification in the end of the shipment. And 30% is quite significant. It's important to say here that liquefaction is basically refrigeration at a very low temperature. And also regulations against greenhouse gases that again will impact this sector as well. Now, this enabling and limiting factors suggest that the LNG sector in future will keep growing its infrastructure, but will also look for the ways to reduce the cost of liquefaction. And liquefaction means refrigeration. So once again, a very advanced product, this time in the energy sector, which requires a sophisticated refrigeration system, which is again affordable, efficient, preferably environmental friendly, but at this low temperature, regulations do not influence it that much as, for example, in the frozen food sector. And having this system, the sector could potentially be more competitive with this LNG product and compete with the conventional industry. After looking at each industry that uses low temperature refrigeration individually, let's take a look on a map and see a bigger picture. European Union is a leader in the frozen food market with a share of 35% and is expected to hold its position until 2025 or so. North America has 20% share in the market of the frozen food, and Asia is expected to become the leader in this market after 2025. North America is a leader in freeze-drying market with 30% share, and this is due to high standards of healthcare and extensive research and development. However, Europe is not far away from North America with 25% share in freeze-drying market. And again, at this point, the fastest growing market is in Asia. So we should expect that in foreseeable future it becomes a leader. Now, North America is also a leader in biobanks market, and this is with 37% share, and due to similar reasons as for the freeze-drying market, high standards of healthcare and research in this sector. Europe has 30% in biobanks market. Asia is an emerging market with 18% share, but again is expected to become a leader in the foreseeable future. The leading market for high temperature superconductors is, however, Asia with 45% share, followed by Europe with 25% share and North America. So looking at the bigger picture, we can already see that we have North America, Europe, and Asia as three centers for current and potential of these sectors that operate low temperature refrigeration, and rightfully so, because as we discussed, we are talking here about the most advanced products and services. They require low temperature refrigeration. Not surprising, they're located currently in developed economies and are expected to become the leader in Asia after the economic growth saturates. Liquefied natural gas has a slightly different image. Here we see the main producers of liquefied gas: Nigeria, Qatar, Australia, Malaysia, Indonesia, and they export liquefied natural gas also mainly to Asia, and main importers of LNG include China, Japan, South Korea, Taiwan, and India. So what we observe here is quite significant industry of low temperature refrigeration that is expected to grow in the future. This growth will define a stronger demand for efficient, affordable, controllable, eco-friendly refrigeration systems in order to satisfy the markets with value-added, superior products that the analyzed industries could produce. So what we should expect in the future, and where is the window of opportunity? We think we're facing commoditization of cold and the increase of demand for suppliers of eco-friendly kilowatts of cold with low cost and high quality. We have analyzed different trends in sectors that use low temperature refrigeration. We see how these markets will add into the global economy more than 15 billion each year. We also see how there is a growing demand for value-added products which are produced using low temperature refrigeration. And in order to manage this demand, different sectors will need to restructure and adapt. We have seen how food producers will most likely increase the scales of their production and will attempt to increase the quality. For that, they need low temperature refrigeration, cheap refrigeration with high quality. Freeze-drying sector undergoes standardization and increases scale through centralization in order to make freeze-drying systems more affordable and produce more value-added products based on freeze-drying. Biobanks obtain more public support and also undergo standardization and centralization to increase profit margins for their operation. And superconductor industry will be looking for opportunities to reduce the cost of refrigeration, as well as the industry for liquefied natural gas. So we see this global picture, and this trend suggests the following consequences. We should expect an increase in commoditization of refrigeration. There will be a growing demand for contracted, specialized suppliers of kilowatt of coal. Not equipment, but kilowatt of coal. There will be a growing pressure to reduce the cost of kilowatt of coal and increase the quality. And by quality, we understand here eco-friendliness and the capability to control refrigeration in a big range in the negative temperatures. You could compare this situation with the example of the power industry, where in order to power, for example, a house, one needs to use, let's say, 100 of diesel generators, or could use a larger single unit power plant. In this scenario, instead of selling freezing equipment, we could consider an alternative business model. In this business model, the suppliers of coal sell kilowatts of coal through the operation of local freezers owned by the supplying company. This situation will help to reduce the cost of kilowatts of coal through specialization, will increase customer satisfaction by removing the burden for technical operation of this equipment, because in the end the customer does not need to operate the equipment. The customer needs the kilowatts of coal produced. But in order to satisfy these conditions, the suppliers of coal would need to have a sophisticated, eco-friendly refrigeration systems with high controllability and quality of produced kilowatts of coal, in order to support sophisticated technological processes in different segments that we analyzed in frozen food industry, in freeze drying equipment, in biobanks, in superconductors, in LNG. And as the CEO of Cleveland Cliffs said, Alvar Lorenzo Gonsalves, in order to do this, we need two things. One, the will to do it, and two is the technology to do it. Well, we have the will to do it, and we have the technology to do it, but we will talk about the technology and why we think that it has technological capability that can satisfy the future for low temperature refrigeration industries, and we will talk about it in future videos. Thank you for your attention. Please subscribe to our YouTube channel, Project Snow Queen. If you have questions, ideas, or comments, please do not hesitate to share it with us on our Facebook page, Project Snow Queen. Please also note that this project is a non-commercial activity and is created in order to inform public about principle of operation, advantages, and potential of implementation for our new regenerative refrigeration system that was built jointly by Skoltech and Thermal Motors Company. Bye.